sedimentation
Okay.
rate. Depends on your burial rate. Is that what you're going to show?
Well, we're not going to well, anyhow, we're going to show, I think, that it's still not the steady state after 20 years.
Right, sure.
Yeah.
It's tenths of a centimeter per year, so you got 100 years.
Oh, Lord. Okay, so away we go. We run that. And in the spirit, by now we kind of know what we got to do. We're going to move the water quality output. We ran temperature, so we'll call this temp. And we ran the sediment. Now we're going to call this G3. Okay. Everybody with me? So now we shrink this. We get our old friend FileZilla. Only now what we're going to bring down are our round 2 files. So we're going to put your finger on control. Let's get the salt, the temperature, dissolved oxygen, G1, G2, G3. Yeah. I'm surprised. Well, I hope I'm doing this right. Okay. In any event, we've got that. Just grab one and drag it on over. And our old friend FileZilla is bringing that down for us. Everybody there? So we've got it on our PC. We'll open up our Excel again. And what are we going to do? Open other workbooks, recent workbooks. I don't want that. I don't want that either. So what I've done is I've navigated to my folder, and if you recall Excel, if you would shut it down completely, it's going to try to open all Excel files, so you've got to say all files. So just because we didn't plot DO before, let's open up DO this time. Next, next, finish. And I'm going to go to box 23. 23 is the bottom of the bay near the head of the bay. And I hope I did this right. There's a plot of dissolved oxygen. A couple of things. So it actually goes down to 0. But you also see that there's no transition. You know, by running the model for 10 years, we've effectively equilibrated dissolved oxygen. We have brought it into equilibrium, if you will, with the forcing functions. And that largely, all right, so remember the water column had about a 2-year time scale. But the sediments for the G1 and the G2, 7 or 8 years to bring that G2 into equilibrium. And it probably didn't show up here, but until that G2 equilibrated, the oxygen would have been changing slightly. So we've learned, and we'll learn the lesson again, you need to run the model 8 or 10 years. If you make a change, we showed how long to equilibrate to initial conditions. We're not going to have time, but let's say instead we were going to do a 40% nutrient reduction. You've got to run that at least 10 years. Just run it, create a new set of initial conditions, then run it again. And the second time is when you actually look at that and say, this is the result of my scenario. And we'll see that. Let's do 2 more. Let's open up. Let's open up the G1 carbon round 2. So this is the G1 carbon, the labile carbon, after we've spun for 10 years. And we'll look at, we'll go next, finish. Let's look at box, well, what the heck, box 3. That's right there under that anoxic portion of the bay. And we'll Control click. Okay. What you see is that there's no variation. You know, the G1 is perfectly equilibrated. Now, actually, what we learned earlier was that takes maybe 2 years, so we expect this. But just in general, if you use as a guideline, we need to run the model 10 years to equilibrate, G1's not going to be a problem. It's going to be there. Let's do another one. Jan, what one are we going to open up this time? G2. He's on. Okay. So let's open up the G2 round 2. Let's, just for curiosity, wow, look at that. Well, let's look at box 3. Okay. So for practical purposes, our G2 is equilibrated. It's actually changing ever so slightly if you inspect, but for practical purposes, after the 10-year spin-up, we actually saw it took about 7 or 8 years. But after the spin-up, if you spin the model, if you run for 10 years to equilibrate, to come into equilibrium with the forcing functions, you don't have to worry about your G2. And last but not least, let's do the G3. Okay. It's still going. The G3 is not, if you look at it, it's not quite equilibrated. Now, I wish I had saved the one from before. It's actually going it's changing very slowly. I wish I had saved the previous one. If we looked at the previous trajectory, it's starting to come into equilibrium. All right, so what do? Do we run another 10 years or do we run another 20 years? We stop here. All right, what we're going to say is 2 things. The G3 is close enough to equilibrium, and secondly, it's inert anyway. You know what I mean? It's practically non-reactive, so why worry? The only time I ever worry about this is if let's say I have some data on sediment carbon concentration or sediment nitrogen concentration that the people collect from cores in the bay. That has a lot of G3 in it. So then you want to get pretty close to an equilibrium condition. You may want to run this another 10 years or something like that. But in terms of things that you care about, like dissolved oxygen in the water column, ammonium in the water column, this fact that the G3 isn't quite equilibrated, we're just going to write it off. And also, a lot of times, like in model calibration or something, you don't start from some uniform initial condition that you don't understand. You know, let's say that I didn't like the algal growth rate or the chlorophyll concentration in this model run that I just made. I'm going to run another one. I would still take the initial conditions output from this model and run it again, loop it. And that would give that G3 even more time to at least approach an equilibrium. So unless you make really dramatic changes, maybe a 40% nutrient reduction or something like that, the G3 is kind of going to, you know, it's going to approach equilibrium as you keep looping and looping and looping model runs. So, hey, one exercise, that took a long time, but it was a useful exercise. What we saw was how to start the model up from nothing, from scratch. We saw how to loop the model, and we saw how long it would take Chesapeake Bay, how long it takes Chesapeake Bay to equilibrate to new forcing functions. Water column about 2 years, sediments 7 or 8, something along those lines. So before we shut down this activity, are there any questions or comments about what we've done? Oh, we got one.
Suppose you're making a projection run, or you're making a real calibration. Your normal procedure is just keep looping over and over and over again, hoping that the system is equilibrating close enough to. But presumably the model in 1987 equilibrated against 1986. So do you tend to run sequential years occasionally just to make sure that's okay? Or?
In practice, if let's say our calibration period is 91 to 2000, we would just keep looping. So in effect, Dominic's got a point, which is if we run our model from 91 to 2000 practically, we're looping it. In fact, if we loop it, we take the output from 2000 and it becomes 1991 again. A small flaw potentially, but that's what we do.
Yeah, I don't think it amounts to much, but just so you know.
Yeah.
You know, it might be to always start with the 91 initial condition. If you absolutely don't change that, then you can see what's happening.
Yeah. But I mean, I can say what the Bay program does is if we do a projection, we loop for 10 years and we start at the beginning again. And there may be some transient in there.
You're getting the last 3-year average, essentially.
Yeah.
Yeah, G3 is always going to be out of equilibrium.
Well, it
because
doesn't
you're doing
matter.
an
It's
interannual
not
run.
doing anything.
You just want to get it in the ballpark at the beginning, but as you go through that sequence of interannual.
No, the G3 is doing nothing. It's just non-reactive. All it's doing is piling up inert material in G3. So the only reason you want to get it equilibrated is you want to take the core out of the model and actually look at sediment carbon. You're not looking at sediment carbon, ignore it. Everything else is equilibrating in 8 years or 5 years. So that's more than enough. But just remember what happens in the loop. You're starting back in the initial condition that's 10 years ago.
Yeah. You know, if
Starting at the 20 initial condition back in 91. It doesn't matter much, just so you know.
yeah. Other questions or comments? Everybody feels good. Dominic?
Terrific.
Okay, thank you. We better run, right? The soup's getting cold. I don't know. Dave, I think for this portion we're wrapped up.